And speaking about the AP exam and kind of AP questions, just going to solve a couple AP questions in this video. I just kind of see the wording that'll happen and kind of prepare you for the upcoming unit test. All right, so that G and H be functions defined by these. If f is a function that satisfies that inequality, what is the limit as x approaches -1? So this is helpful because it's in the same video series, but whenever you see this kind of thing around a limit, oops, I kind of wrote over that, around a limit, that's your hint that this is a squeeze theorem problem. F is getting squeezed between G and H, and we're trying to find a limit at -1. So whenever you see those kind of things together, it's a squeeze theorem problem. And the only way the squeeze theorem applies is if I plug in -1 into G and H. If those two things end up being the same, that means they squeezed f of x to also be the same. So really what I'm going to do is just plug in -1 into G. Being careful with all these negatives. And I'm going to simplify it. And I get 4. I'm also going to plug it into H. That's going to be 1/2 minus 2/2 plus 13/2. And now's where I decide if I made a mistake or not. I actually did make a mistake, but it's not going to change the problem. Again, it won't let me erase for some reason. This should be a 12, which makes this a 6. All right. So the G function ends up being 4. The H function ends up being 6. So if G is always below F, I just say this is like F dancing through there. G comes up and it hits 4. H comes down and hits 6, but this doesn't tell me enough to figure out what the limit of f is. What I need is for these two things to squeeze f. So if I had gotten, say, 5 for both of them, they've squeezed to the exact same point. They're both 5, and that would be the answer. All right, but since they're not equal to each other, I have to say I can't determine what the answer is. So really for these types of questions where you recognize the squeeze theorem, figure out the two limits. If they're the same, that's the answer. If they're not the same, you can't figure it out from the information that's given to you. We have no idea what f is, so we know it's between 4 and 6, but that's not enough to know what the actual answer is. All right, for this one, we're trying to find this limit. Again, the first thing I would always do with a limit is try to plug in the number. I don't know why I'm writing so small. 9 minus 9 over 9 plus 6 minus 15, which is 0/0. So 0/0 is a really good sign that you can factor it because there's a common factor on the top causing those zeros. So now I factor my problem. All right, so at the top is the difference of squares. At the bottom, I'm looking for add the -2, multiply to 15, so that's going to be -5. +3. And technically you should have the limit in front of this. This is a nice thing with multiple choice questions. It doesn't matter how bad your notation is, as long as you get the right answer. But we can see this common factor of x plus 3 cancels out. So this is going to be the same as the limit without those x plus 3's. And now I can just plug in -3. -6 over -8, which is +3 over 4. All right, so our final answer is C. All right, 3 over 4. All right, so again, figuring out our limits, we know all these properties now. With this one, you can simplify and get your answer. What is the limit? In this case, again, the nice thing with the video is you could try to pause it and figure it out yourself and then kind of see if you get it right. It's kind of a good way of figuring out if you're on the right track. But for me, if I'm trying to find the limit as x approaches 1, first thing I do is try to plug in 1. And I know I get 0/0. Again, 0/0 is a good sign that something is going to cancel out. If it was a number over 0, that's not a good sign, but 0/0 is a good sign. Something's going to cancel out. So I'm going to start out with x squared minus 1 over the square root of x minus 1. And again, we saw this in our videos. Whenever you see that square root when you're doing a limit problem, that's a good idea. It might be a conjugate problem, so let's do the conjugate and see if that works out for us. And again, sometimes it doesn't, sometimes it does. So on the top, we're going to leave it all separate. On the bottom, where we're actually multiplying by the conjugate, we're going to actually FOIL it out, which is going to be x minus 1. Then that common x minus 1 will cancel. We get x plus 1 times the square root of x plus 1. And again, the whole time I should be writing this limit. I'm just being lazy. Because that tells me now that I got rid of that fraction, I can plug in 1. My final answer is going to be 4. And this is where it's helpful to know all the different techniques, because this one would be really hard to do without knowing that conjugate trick of multiplying by the square root part. All right, and one more. All right, h is a piecewise linear function such that the limit at 3 does not exist. Which of the following could be representative of the function h? So one thing, make sure you read it carefully. It's a piecewise linear function. All right, so they're made up of straight lines. All right, we're looking for the limit does not exist at 3. All right, so we said that basically, this is kind of a tricky thing by the AP exam. They're basically breaking this one problem into 3 separate problems, because for each one of these 3, you have to figure out, does the limit at 3 exist? If it does exist, it's not going to work. If it doesn't exist, then it fits their description. So for the first one, I'll do it in blue. We're trying to figure out, will that limit exist? All right, we're looking at a piecewise. There's these possible jumps that happen. So we'll look at the left of 3, which is when we'll be using the top function, and we get 9. We're looking at the right of 3, we'd be using the bottom function. And we also get 9. So the left-hand limit, the left 3 equals the right-hand limit, which means the full limit at 3 itself is equal to 9. All right, so that's the number. That means it doesn't exist. So automatically 1 is out, so we can get rid of that answer. All right, skip the table for now and look at the graph. So the next one is number 3 down here. All right, is the limit going to exist at 3? Well, 3 is right here. And there's 3 reasons limits don't exist: jumps, asymptotes, and oscillation. And right now we have this jump at x equals 3, which automatically means the limit does not exist. So the limit does not exist for this graph, which means 3 is definitely one of the answers. So now we just have to decide, what about 2? Well, it's important to remember this one. All right, 3 to the left of 3, we're looking at these values. To the right of 3, we're looking at these values. It doesn't matter what's happening right at 3, because limits are what's happening around it. On the right side, it's pretty obvious, 3, 2, 1, 0. So on the right-hand side, it's going to 0. On the left-hand side, all right, so 3, 8/3, 7/3. All right, not super obvious, but if I rewrite 3 as 9/3, now you can see the pattern: 9/3, 8/3, 7/3. It's going to 6/3, which is 2. So the left-hand numbers, the pattern makes it look like it's going to 2. The right-hand numbers, the pattern looks like it's going to 0. Again, those two numbers are not the same, so our answer has to be D. All right, they're not the same, so the limit does not exist, which means 2 and 3 are not the same. And actually, if you look at it, the numbers in the table here perfectly match up the picture here. So that's 0, 3, 1, 8/3, 1, 7/3, basically 2, 3, 2, 1, 0. So since 3 does not exist, 2 also does not exist. All right, so those are some types of AP problems you might see when in relation to limits.